Hello friends, I am Nimai Godai. Today we are going to talk about beta oxidation of fatty acids. We have already discussed about the overview of metabolism of lipids which you can see in my previous videos. Today we will talk about beta oxidation of fatty acid. In the beta oxidation, fatty acids are broken down into acetyl coenzyme A. Acetyl coenzyme A will enter the citric acid cycle and form the carbon dioxide. The electrons released from the oxidation will be accepted or carried by the NAD plus or FAD, and it will enter the respiratory chain. Ultimately ATP will be formed, energy will be formed. So in the beta oxidation, the 14 carbon compound, let's start with myristic acid, which is a 14 carbon carboxylic acid. It will break down into 7 molecules of 2 carbon compound, that is acetyl coenzyme A. So it is very easy to count the number of acetyl coenzyme A formed by the breakdown of any acid. For example, if there is 16 carbon carboxylic acid, then it will form 8 molecules of acetyl coenzyme A. Because acetyl coenzyme A is a 2 carbon compound and palmitic acid has 16 carbons. Well, beta oxidation is not a single step. It completes in 4 steps. Beta oxidation has 4 basic steps which we will discuss. Yeah. So, the formation of 7 molecules of acetyl coenzyme A from 1 molecule of myristic acid completes in 24 steps. In the first 4 steps, the 14 carbon compound is broken down into 2 carbon compound and 12 carbon compound. In the next 4 steps, the 12 carbon compound will break down into 2 carbon compound and 10 carbon compound. In the next 4 steps, the 10 carbon compound will break down into 2 carbon compound and 8 carbon compound. In this way, finally the 7 molecules of 2 carbon compound will be formed, and to this 2 carbon compound is nothing but acetyl coenzyme A. Now we will discuss the 4 basic steps of beta oxidation. Here we can see that myristoyl coenzyme A, which is a 14 carbon fatty acid, will convert into acetyl coenzyme A and a 12 carbon compound. So here there is 4 basic steps. First, the myristoyl coenzyme A is oxidized into trans delta 2 enoyl coenzyme A. So the enzyme for this reaction is acyl coenzyme A dehydrogenase, and the electron carrier FAD has accepted the electrons and hydrogen, okay, and reduced to FADH2. In the second step, the trans delta 2 enoyl coenzyme A will convert into L-beta hydroxyacyl coenzyme A. So this is a addition of water. In the third step, the again oxidation occurs. L-beta hydroxyacyl coenzyme A will oxidize into beta ketoacyl coenzyme A. Here you can see the hydrogen atoms of beta carbon has removed. Okay. Now in the fourth step, beta ketoacyl coenzyme A will break down into 2 carbon compound and a 12 carbon compound. This 12 carbon compound will again follow the above 4 steps, and finally 7 molecules of acetyl coenzyme A will be formed from a myristoyl coenzyme A. Similarly, if there is 16 carbon fatty acid, that is palmitoyl coenzyme A, it will break down into 8 molecules of acetyl coenzyme A.